All right, so today we're going to take a deep dive into something that's pretty essential if you're interested in C programming at all.
Yeah, for sure.
We're talking about building your very first C library
Mm-hmm.
called Livft.
Cool.
And if you've ever, been even a little curious about coding, especially in C, or maybe you're prepping for a coding project that just seems kind of daunting,
Right.
this deep dive is definitely for you.
Yeah, this is going to help you level up those C skills.
Absolutely.
For sure. So what we're
Nice.
really talking about here is building your own personalized toolbox
Okay.
for C programming.
I like it.
C libraries are these collections of pre-written functions. It's like having a whole bunch of ready-made solutions
Right.
for common coding problems.
Andy.
Yeah, and with Livt, you're not just going to learn what these functions do, you're actually going to build them yourself.
Oh, so it's not just about using the tools, it's
Yeah.
about understanding how they're made.
That's exactly right. The source material we have actually emphasizes that Livt is all about understanding how the nuts and bolts of those standard C functions work. It's like learning to bake from scratch before you start using those boxed cake mixes.
I like that analogy.
Yeah.
So, okay, I'm starting to see the value here, but wouldn't it be faster to just use those pre-built functions?
Mm-hmm.
I mean, is it really worth the effort to recreate them from scratch?
That's a great question. It might seem like extra work,
Yeah.
but trust me, the insights you gain from actually building these functions yourself are invaluable.
Really?
You'll develop this deeper understanding of how they actually work, which makes you a much more effective debugger and a more resourceful programmer overall.
So it's like the more you understand how the engine works, the better you are at fixing it when something goes wrong.
Exactly.
That,
Plus, think about the long term. As you add more and more functions to your Lyft, you're essentially building this custom toolbox that's perfectly tailored to your coding style and the kinds of projects that you work on. And you can even use these functions in your future C programming assignments.
well, that's a good point. Yeah.
Talk about a head start.
Yeah, no kidding. Okay, I'm convinced. So let's get into this Live project. What's the structure? Like, is it just like a giant pile of code, or is there some kind of organization to it?
Oh, it's definitely organized. The table of contents in our source material lays it all out.
Okay.
There are two main parts to this project.
Okay.
The first is all about recreating functions from the standard C library,
Right.
sometimes called Libft.
Okay.
So this is where you rebuild those essential functions that every C programmer uses.
So we're talking about like those classic functions like strillen for finding the length of a string, or mcpy for copying chunks of memory.
Yeah.
Like the kind of stuff you find in those massive C programming textbooks.
You got it. And the cool thing is you're not just copying code blindly. You're
Yeah.
actually figuring out how to implement these functions from scratch,
Okay.
which forces you to understand the logic behind them.
That makes a lot of sense.
Yeah.
So what's the second part of the project all about?
Well, once you've mastered the classics,
Mm-hmm.
it's time to compose your own symphony, so to speak.
Oh.
The second part is all about building additional functions.
All right.
These are functions that are either not in the standard C library or they exist in a different form.
Okay.
And this is where you really get to flex your creativity and problem-solving skills.
So it's like taking all those basic building blocks you learned in the first part and using them to create something entirely new.
It is, and the source material provides a really interesting list of these additional functions.
Oh, cool.
There's one called fstrum, for example.
Okay.
Imagine you're working with some messy data
Mm-hmm.
that has like extra spaces or weird characters at the beginning and end.
Yeah, I've seen that.
This function lets you clean all that up,
Oh, nice.
so you can make your data much easier to work with.
So it's like a digital cleanup crew for your data. I can definitely see how that would be useful in a lot of different situations.
Absolutely. Another one that caught my eye is split.
Okay.
Think about how you might need to break a sentence down
Right.
into individual words.
Okay.
This function does exactly that. It splits a string up based on a specific character, like a space.
So if I wanted to break a sentence down into words, I could use if split with a space as the separator.
Exactly. Or if you were working with a comma-separated list of values, you could use a comma as the separator.
It's blue, right?
It's incredibly versatile.
Very cool.
Yeah, and mastering this function shows that you understand how to manipulate strings at a deeper level, which is a valuable skill for any programmer.
Okay, I'm starting to see a pattern here. These custom functions are all about solving those little problems that pop up all the time in programming.
Yeah.
It's like having a solution ready to go
Right.
for those common tasks.
You got it. And that's what makes a good programmer so efficient. They have this library of solutions that they can just pull from whenever they encounter a familiar problem.
Yeah, that makes sense.
Yeah.
Okay, so give me one more. What other function should I be adding to my coding toolbox?
This one's a classic FTOA.
FTOA. Okay.
It stands for integer to ASCII,
Okay.
and it's all about converting numbers
Okay.
into text. Sometimes you need to display a number on the screen or store it in a file, but computers ultimately work with text.
Right.
So this function handles that conversion for you, even if the number is negative.
So if I wanted to display the score in a game or the number of items in a shopping cart, I could use FTOA to convert those numbers into text that the computer can understand.
Precisely. It's a fundamental operation that you'll use all the time.
Gotcha.
And mastering it shows that you understand how data is represented in a computer.
This Libft project is really shaping up to be an incredible learning experience.
It is.
And like we're building this solid foundation of C programming skills while also creating something practical and useful that we can use in our own projects.
Yeah, it's not just a learning exercise. It's a powerful tool that you can actually use in your projects.
That's great.
But before we dive deeper into those additional functions, there's something crucial in the source material that we should talk about.
All right.
The common instructions section.
Okay.
It might not sound glamorous, but it sets the stage for good coding practices right from the beginning.
Okay, lay it on me. What kind of ground rules are we talking about here?
Well, for starters, there's a strong emphasis on adhering to strict coding norms.
Okay.
Think of it like grammar rules for your code. It ensures that your code is readable, maintainable, and consistent.
Gotcha.
Then there's a big one, memory management.
Ooh, memory management.
The source material is very clear about avoiding memory leaks.
Now, memory leaks, those sound bad. Refresh my memory. What are they again?
Imagine your program is like a house.
Okay.
Memory is like the space inside that house. When you create something in your code, you're essentially asking for some space in that house.
Right.
A memory leak is like leaving a faucet running in one of the rooms.
Oh.
It might seem like a small thing at first, but over time it can waste a lot of resources and even cause your whole program to crash.
Yikes. So learning how to manage memory properly is kind of a big deal then.
Absolutely. And the source material actually has a great anecdote about this.
Oh, really?
It says, imagine a tiny leak in one of your functions now in a larger program. That seemingly insignificant leak could snowball into a huge problem, potentially crashing the whole system.
Okay, that definitely paints a vivid picture.
Yeah.
So attention to detail is key here, right?
You got it. And the source material also emphasizes the importance of avoiding global variables.
Okay.
It's all about keeping your code clean, organized, and easy to understand.
Got it. No cheating with global variables.
Right.
Now, I see the source also mentions technical considerations.
Yes.
Is there anything interesting in there?
Yeah, it builds on those good coding practices.
Okay.
It stresses that if you need to break down a complex function, you should create what are called static helper functions.
Hold on, back up a second. What exactly are static functions?
Think of static functions like those little compartments in a toolbox.
Okay.
They're functions that are only visible within the same file.
Right.
Kind of like hiding your tools away so they don't clutter up the main workspace. This helps keep your code organized and prevents conflicts with other parts of your program.
Ah, so it's all about keeping things neat and compartmentalized.
Exactly.
Good habits from the start.
Right.
Right.
And now that we've laid the groundwork, let's get to the heart of this Libft project.
All right.
Let's break down the mandatory part where you really get your hands dirty with code.
Perfect. I'm ready to roll up my sleeves and dive in.
Great. The mandatory part is divided into two key sections. The first, as we mentioned earlier, is all about recreating those essential functions from the standard C library.
Right, like Strylin and MengPy. So walk me through this. What exactly do we have to do in this first section?
Well, the source material provides a list of these lib functions that you'll be recreating.
Yeah.
There are quite a few familiar ones in there, and you'll learn a ton about how they work at their core by rebuilding them yourself. But there's a little quirk mentioned in the source that's worth pointing out.
Oh.
Something about a restrict qualifier.
A restrict qualifier that sounds ominous. What's that all about?
It's actually not that complicated. It turns out the restrict qualifier was introduced in a later version of the C standard.
Okay.
And it's not allowed in this project.
Got it.
It has to do with how the compiler optimizes code.
Mm-hmm.
And for this project, we need to stick to the older standard, so you'll need to be mindful of that when you're recreating certain functions.
Got it. So A little bit of a historical detour, but we'll figure it out.
Right.
Anything else stand out in this first part?
Yeah, there's a specific instruction regarding the callic and straight-up functions.
Yeah.
The source material says you'll need to use the malloc function to implement them properly.
Now, for those who are new to C malloc, is the way we ask the operating system for a chunk of memory to use in our program, right?
That's exactly right. And this reinforces what we talked about earlier. Memory management is a crucial part of C programming.
Right.
Even when you're recreating these basic functions, you're starting to understand how memory works in C and how to use it effectively.
Okay, so even in this first part of the mandatory part, we're getting a real taste of what it means to be a C programmer.
Yes.
We're recreating those essential functions, learning about memory management, and paying attention to coding standards.
For sure.
This is starting to feel pretty real.
It is. And the second part of this mandatory part is where things get even more interesting.
Okay.
We'll move beyond those standard functions and start building some really cool, unique functions that'll add a lot of power to your Libft.
This is where we get to be creative, right?
Exactly. But for now, let's take a quick pause and come back in a bit to dive into those exciting custom functions.
Sounds good. Okay, so we're back and ready to tackle the second part of this mandatory part in the Libft project.
All right.
And this is where we kind of get to move beyond, recreating those standard C functions.
Right.
And start building our own custom functions, right?
Absolutely. This is where you really get to unleash your creativity and problem-solving skills.
Okay.
The source material gives us this whole list of custom functions to build, and they cover a surprisingly wide range of tasks.
So it's like we've learned the basic moves, and now it's time to choreograph our own dance.
I like that analogy, and just like a good dance routine, these functions are all about combining those basic steps into something more complex and expressive.
All right. I'm excited to see what kind of moves we're going to learn. Give me an example of one of these custom functions that really stands out to you.
Well, one that caught my eye is stroke trim.
Stroke trim.
Okay. Remember how we talked about cleaning up messy data with extra spaces or weird characters?
Yeah.
This function does exactly that. It's like having a digital barber for your strings.
Okay.
Trimming off those unwanted characters and leaving you with clean, usable data.
Wow, that's really practical. I could see how that would be useful in so many situations. Like if you were building a program that processes user input.
Right.
You could use ifstrim to make sure that the data is all cleaned up before you do anything with it.
That's a great example, and it highlights why building your own Libft is so valuable. You're not just learning these abstract concepts, you're developing these practical skills that you can apply to real-world problems.
I like it. Okay, so ifstrim sif is definitely going in my coding toolbox. What other cool functions are waiting to be discovered?
Well, how about if split? Remember we talked about breaking a sentence down into individual words?
Yeah.
That's exactly what this function does. It takes a string and splits it into these smaller strings using a specific character as the separator.
So I wanted to break a sentence down into words. I could use if split with a space as the separator.
Exactly. Or if you were working with a comma-separated list of values, you could use a comma as the separator.
Right. Makes sense.
It's incredibly versatile.
That's cool.
And mastering this function shows that you understand how to manipulate strings at a deeper level, which, again, is a valuable skill for any programmer.
Yeah. Okay, I'm starting to see a pattern here. These custom functions are all about solving those little problems that pop up all the time in programming.
Yeah.
It's like you said, having that solution ready to go for those common tasks.
Exactly.
All right, give you one more. What other function should I be adding to my coding toolbox?
This one's a classic ftitoa.
Ftitoa.
It stands for integer to ASCII.
Okay.
And it's all about converting numbers into text. You know, sometimes you need to display a number on the screen or store it in a file.
Right.
But computers ultimately work with text.
Right.
So this function handles that conversion for you, even if the number is negative.
So if I wanted to display the score in a game or the number of items in a shopping cart, I could use Chitoa to convert those numbers into text that the computer can understand.
Precisely. It's a fundamental operation that you'll use all the time. And mastering it shows that you understand how data is represented in a computer.
This Libft project is really shaping up to be an incredible learning experience.
It is.
It's like we're building the solid foundation of C programming skills while also creating something practical and useful that we can use in our own projects.
Yeah.
So it's kind of the best of both worlds.
It is. And there's one more section in the source material that we need to talk about, the bonus part.
Okay.
This is where things get really interesting.
Right.
Especially if you want to take your C programming skills to the next level.
Okay. I'm intrigued what's lurking in this bonus part.
It's all about linked lists.
Linked lists, okay.
Now, I know that might sound a little intimidating, but trust me, linked lists are one of the most fundamental and powerful data structures in computer science.
Really?
They're used everywhere from databases to operating systems.
Wow. Linked lists.
Ah,
I've heard of them, but they've always seemed a bit mysterious to me.
yeah.
Can you explain them in a way that even I can understand?
Sure. Imagine you have a bunch of boxes,
Okay.
and each box contains a piece of information.
Right.
Now imagine that each box also has a little arrow pointing to the next box in the line. That's essentially a linked list.
All right.
It's a way to organize data sequentially,
Mm-hmm.
but with a lot more flexibility than an array.
Okay, that's not as scary as I thought. So
Oh.
each box is like a node in the list, and the arrow tells you where to find the next node.
Exactly. And the source material actually defines a specific structure called tootlist.
Okay.
To represent each node in the linked list, it has space for the data you want to store
Mm.
and a pointer to the next node in the list.
So if the pointer is empty, you're at the end of the list.
Right.
That's pretty clever. But what kind of things can you actually do with linked lists?
Oh, you can do all sorts of things. You can create new nodes, add nodes to the beginning or end of the list, remove nodes,
Okay.
search for specific nodes,
Uh-huh.
sort the list, and even iterate over the entire list to perform some operation on each node.
It sounds like they're incredibly versatile.
They are.
But why are they so important? Why should I care about linked lists?
Well, for one thing, they're incredibly efficient for certain tasks. For example, if you need to insert or delete elements in the middle of a list,
Okay.
a linked list is much faster than an array.
Oh, interesting.
And because they're so flexible,
Right.
they're used in a wide range of applications, from managing memory in an operating system to storing data in a database.
Okay. I'm starting to see why mastering linked lists is a big deal.
Hmm.
But this is the bonus section, right? Does that mean it's optional?
Well, technically, yes. The source material says that the bonus part is only assessed if you've perfectly completed the mandatory part. So it's
Okay.
like a challenge for those who really want to push themselves and
Yeah.
go above and beyond.
So it's like the final boss battle in a video game.
Yeah.
You have to beat all the other levels first before you can face the ultimate challenge.
I love that analogy. And just like a final boss battle, mastering linked lists requires a solid understanding of all those foundational concepts we've been talking about.
Right.
Things like memory management pointers, good coding
It
practices.
sounds like a real test of skill, but also an incredibly rewarding experience.
Absolutely. And the source material makes it clear that even if you don't complete the bonus part, understanding the concepts behind linked lists will make you a better C programmer.
So it's like a secret level
Yeah.
that unlocks even more potential.
Exactly. And now that we've explored the structure of this Libft project,
Uh-huh.
from those essential functions
Right.
to those challenging linked lists, let's take a step back and think about the bigger picture.
Okay.
What does all of this mean for you, our listener? Why is this project so valuable?
Yeah, let's connect all the dots. We've covered a lot of ground. But what are the key takeaways here? What should our listeners be thinking about as they embark on this libdiff journey?
That's a great question, and it's one we'll explore in more detail as we wrap up this deep dive. But for now, let's take a quick pause
Okay.
and come back to reflect on the bigger picture and those all-important takeaways.
Okay, so we're back and ready to wrap up our deep dive into Libft,
Right.
your very first C library. And we've talked about recreating those essential C functions and building custom functions to kind of solve real-world problems.
Right?
We even touched on the world of linked lists. So
Yeah, we did.
we really covered a lot of ground.
We did.
But now I'm curious, what does all this mean for our listener? Like, what are those key takeaways they should be thinking about as they embark on their own Libft journey?
That's a great question. I think one of the most important takeaways is the power of understanding those fundamentals.
Okay.
By recreating the standard C functions, you're not just copying code, you're gaining a deep understanding of how those functions work at their core.
Yeah, it's like you're learning the secrets behind the magic trick instead of just being amazed by the illusion.
Exactly. And that deeper understanding is going to make you a much more effective programmer.
Yeah.
You'll be able to debug problems more easily, write more efficient code, and even come up with your own creative solutions.
So it's not just about learning the what, it's about understanding the why.
Absolutely. And that leads to another key takeaway, the importance of building those good habits early on.
Right.
Remember those common instructions. We talked about those coding norms, the emphasis on memory management, the avoidance of global variables. Those aren't just arbitrary rules.
Right. It's like the foundation of a well-built house. If you cut corners on the foundation,
Yeah.
the whole structure is going to be weaker.
Exactly. And building those good habits early on will pay off in the long run. It'll make your code more readable, more maintainable, and less prone to those errors.
Makes sense. Okay, so we've got, understanding the fundamentals, building good habits. What else should our listeners be taking away from this deep dive?
Well, I think it's important to remember that Lived is not just a learning exercise. It's an actual practical tool. Oh, right. That you can use in your own projects.
We talked about all those custom functions.
Exactly.
Crush, rem, if, split, fitoa.
Yeah.
Those are functions that solve those real-world problems, and they'll save you a ton of time and effort in your own coding adventures.
Exactly. And as you continue to learn and grow as a C programmer, you can keep adding to your Libft, creating your own custom functions to solve those unique challenges that you encounter.
It's like having a secret weapon in your coding arsenal.
Yeah.
A library of solutions that you've built yourself that perfectly fit your coding style.
I love that. And speaking of secret weapons, remember those linked lists we talked about in the bonus part?
Oh, yeah.
Mastering those is like leveling up your C programming skills.
Yeah, it's like unlocking a hidden area in a video game.
Right.
That's filled with all those powerful tools and treasures.
Exactly. Linked lists are one of those fundamental data structures that you'll encounter over and over again in computer science. Understanding how they work will make you a more versatile and adaptable programmer.
So even if our listener doesn't complete the bonus part, just being exposed to those concepts is valuable.
Absolutely. It broadens your horizons and gives you a taste of those deeper complexities and possibilities of C programming.
Wow, we've really covered a lot of ground in this deep dive. From the foundational concepts to those advanced data structures. It feels like we've given our listener a roadmap to success in C programming.
I hope so. And more importantly, I hope we've sparked their curiosity and inspired them to embark on their own Libft adventure.
Yeah. Because at the end of the day, it's all about that journey of discovery.
Right.
That thrill of building something from scratch and seeing it come to life.
It's about the satisfaction of solving those problems, the joy of creating something useful, and the endless possibilities of code.
So to our listener, we say embrace the challenge, have fun along the way, and never stop learning.
And who knows, maybe someday we'll be deep diving into your custom C library, marveling at the amazing things that you've created.
That's a great thought. And on that note, we'll wrap up this deep dive.
Sound good.
Until next time, happy coding.